So in this discussion we're going to be looking at some of the advances that have been made in ultrasound. We're starting from the point of this image that you can see of colour Doppler. Our course has been about colour Doppler. These are images that are very useful clinically, but in the future we will have colour Doppler that is made not just a few times a second, but many thousands of images a second. And that means that we'll have completely new information. And the images that you can see now show at every point in blood vessels the direction and speed of flow. These images are made at about 4,000 per second. And another development that we'll be talking about is the combination of this technology with contrast agents, microbubbles. Again, these are used clinically now all over Italy, and they're used for diagnosis of lesions, for example, in the liver, like the one we can see here. But if we combine this with the high-speed technology that we are developing, then we can take the kinds of image you see in colour on the left and deduce from it the microvasculature, invisible at the moment to modern radiology, but this technology is able, with the aid of a computer, to track the path of bubbles and map the tiniest blood vessels. And this will improve the resolution and the ability to see very small vascular structures in the body. Finally, we're going to be talking a little bit about the use of these bubbles, not simply to go round in the circulation and enhance the diagnostic ability of ultrasound, but also to add targets that will direct the bubbles specifically to areas of the body where, for example, there is a cancer developing, or where there is inflammation from ischemia, from the lack of blood flow. And here you can see examples of this molecular targeting of bubbles. So molecular imaging, normally associated with nuclear medicine and the use of radiation, will now be transformed into an everyday application of ultrasound in our diagnostic facilities.